Hello, everybody. We live again. So, welcome to my live stream. Uh, if you're joining for the first time today, I'll do a small recap on the idea of those live streams. So, sorry. The idea of those streams is to build a small URL shortener in Go and go through like all the steps to actually get it in a production ready state, right? So, everything from like monitoring, logging, a bit of a code architecture as well, and also all the kind of hardening things like setting proper timeouts and everything. And the idea is like every episode, I'm gonna cover a different topic. So on the last stream, we did a POC, so actually got from a empty file to a URL shortener that actually works. You can post a URL to save it, and then you can access it. However, the URLs are stored in memory. So if you stop the process, you lose it. If you have more than one instance running, they're gonna create independent, but it works to prove like the URLs work. the You can actually make it work. So that's very basic proof of concept. For today, my goal is to actually iterate a bit on that and add some features and talk about structured logging. So as you can imagine, when you have an application running, you need to know what's going on sometimes, right? You need to know if it's healthy, if it's facing any issues, if it's facing issues, why it's facing issues. And one of the easiest ways of actually knowing what's happening in your application is just to log some stuff. It's basically printing some statements when you go through some parts of the code to indicate what's happening. And we actually introduced the very basic logging in the last stream using the standard log package from Go. And then today we're gonna iterate on that and improve it and actually get to the point of using structured logging that I'll introduce this concept later on. So as a recap, let's see what we have. So we have a very basic DB type that we can set a value and then you can get a value from it. And of course we have one handler. And your handler or handler has two a handler type has actually two handlers implemented, two HTTP handlers implemented, one to save the URL and another one to actually access the URL that you called get. So and you have them rested here, save and go. So if you call or like base URL slash save with the URL, then we get a token, random string back. That's like the shortened URL. And then you have the other one that actually goes there. And then if you actually access slash go, query string 2, and then this token that's a UID v4, you're gonna go there. So let's just quickly see it working. And then we can do more stuff. Do I have my terminal? Yes, I have my terminal here. So go run. I could do go run slash main dot go. That's the traditional one. But actually there is a trick. You can do go run and dot. And then go to finds the main package and runs it. And actually names the binary after the main package. Okay, so we have HTTP server running at port 3000. If I go to the browser, let's see if I get the right, yes. So localhost 3000 save. And we have an example here. So, and then you get your new URL is that one. And we should be able, and then we can also, if you switch back, you can see that URL was saved. We're actually saving the actual URL, the UID for the URL and the URL. And it appears twice because I use actually F5 to switch to my Emacs. Okay, if you go back to the browser, you have the code here, and then you can do localhost, instead save, we go, string to end the UID and we have your Go website. Let me make it dark. So yeah, so it works, right? And we have this very, very basic login here that actually says the name of the handler, save and get, and some of the parameters. Okay, how did we implement it in the last stream? Okay, our main.go is very simple. At the end of the main.go, we log that we're going to start HTTP server, and then we start it. That's fine. However, that log is saying like which actually URL was accessed. It's inside the handler, right? So every handler have at the very end log println with the message of the name of the handler and some information. So that's true for the save URL handler, and that's true for the get URL handler. And you can see that starts to get repetitive, right? If every single handler I have to add, like remember to add login there, it's very likely that in some of them I'm gonna forget. And so how can we improve it? So what we can do, we can actually write a HTTP middleware that for every single request you receive is gonna log the request, right? So HTTP middleware basically is a HTTP handler, a standard HTTP handler that can receive a handler, do some operations before running the handler, run the handler, and then can also do operations after the handler. So the most basic form to implement an HTTP handler in Go is a func that's gonna receive, I need a name, I always struggle to write that, middleware. It's gonna receive the next handler, that's http.http, not hto handler, and it's gonna return http.handler. Turn nil, so my linter doesn't complain. Okay. So what we have to do here for this actually to work? I can do something. So for this actually to work, I need to call the next HTTP handler, and I need to return actually an HTTP handler. So let's create the HTTP handler I'm gonna return. So we can define a function locally. So fn is a func that receives a w, that's http.responseWriter, writer, and r, that's a pointer to http.request. And I don't know why my autocomplete is not working. And then we're gonna return fn. Now I need to do http. I need to convert it. Handler fn. Okay. So literally I have an empty http. Fn is an empty function that can implement the HTTP handler interface when I wrap it with this HTTP handler func. And then if I actually want to run the next handler, I need to do next wr if I don't want to modify. And add next.servHTTP because I'm receiving the interface. So that's literally like an empty HTTP handler, right? As this is receiving a function here, so that's the function that's actually gonna run every time. If I need to do some preparation, that's only gonna happen once. When I'm instantiating the middleware, I can do before outside of the function I define, and things that should happen all the time, I'll do on the function. So just to do a very simple demonstration, let's just log something. Log.print. No. Great, my keyboard is set up wrong. 1 second. And that's what happens when you forget to fully test your keyboard. Okay. Okay, so now my keyboard's set up right. Hello, my keyboard is broken. Let's print my keyboard was broken. Broken. And I need to memorize better my keys. Okay. So we have this middleware. How can we use it? If you go back, basically you can just wrap it with middleware. Because if you remember, and I mistyped that, of course. Save. I can use direct handle. I don't need handle func anymore. Save URL is not an HTTP handler, it's a handler func. Yes, I need HTTP handler here. HTTP dot handler func. So what I did, so the save now it's rapid. So basically what I did, I got our h.save URL that was a HTTP handler func rapid in with this HTTP.handler func. So actually it now implements the HTTP handler interface, pass it to my middleware. My middleware returns another HTTP handler that's actually registered under /save. So if all goes right, when I call the save endpoint, we're gonna see that message we wrote in the logs. So let's go to our terminal, run it again, and then I go to my browser, yes, and then if I call save and go back to Emacs, we can see that my keyboard was broken. It's being printed on every request, right? And it's actually printed before the log from the handler. That's because we actually, if we go back to the implementation, we log it before calling the handler, right? And then if you do something proper now, request finished, and you can do like request started here, request started, not capitalized. Oops. Okay. So now we should have like two log lines before any two log lines, and anything that the actual handler log should be in the middle. So let's see that in action, and then this time I'm not gonna change to the browser, just gonna call it. So you see request started, request finished. So we have a middleware, we can log stuff in this middleware, and now we can actually start to do some interesting stuff, right? Because request start and finish is actually helpful, but we have no information of what was started and finished, right? So if we keep using the standard library logger, so let's do a print f, and then request is started, URL, it's a percentage s, and then let's put also the method, HTTP method, that's also a string. So the URL we can get from the request.url, not the user agent, URL dot string URL string, and I said that I was gonna put something else there. That was the method. R.method. Remember, yes, that's a string. Okay. So you can see that request started and finished. Okay, okie dokie. Let's try it again. Okay, request is started, the URL /save URL, and the method was get. If you actually want to get the host, it is somewhere else. But yeah, we can see that, right? And if I keep hitting it, refreshing the browser, we see, right? And then actually, if for some reason I actually do the go, I'm just gonna open the other one so you can see the logs. Go to, have an easier way to do that. And it's not working because I stopped the HTTP server because I'm very smart. Okay, the HTTP server is running. I want to show you that what happens when I do the go, because that's not rapid from middleware, right? So the go, as you see, get URL. Let me refresh, run it again, and they have the wrong token. And you see we don't have request started ended because we didn't wrap that middleware, that handler, right? And of course, that wrapping every single handler by hand with something that wants to happen every time is gonna get very annoying. And then if you have multiple middlers, is you're gonna have like gigantic lines, and at some point you're gonna forget one. So to facilitate that, the first thing we're gonna do is actually start using a HTTP router. So in Go, there are actually many HTTP routers. I like the GoChi. It's very fast. It has nice middlers. It's very lightweight. It supports context and everything. I think if you'd say I've been using it for like almost everywhere. I have pretty much nothing to complain about it. There are some integrations that are not available for this GoChi. So if you have other requirements that might need to integrate with your HTTP router, you can look into other ones. There's also Gorilla Mux and many other ones, but I use this one for now. So the way it works, you can see the example here. You just need to, of course, go get, import, and then you create a new router. They already have an example actually of a logger middleware here. I'll probably test them. And then you just do r.get, like that's actually the HTTP method that you want to work with. And then on the HTTP listen server, you pass your router. So, okay, let's get G and go get. Let's go back to Emacs. And so go get, go G. Come on, Emacs. Okay. Let's go to our application and we can go to our main function. Okay, let's h handler and then let's do r. That's a g.new router. If I save, it's imported. So what I can do r.use and then I can pass into a middleware if my language server works, but I don't know why it doesn't want to work. I can pass my middleware here. And still not recognizing G for some reason. Is it even important? Yes, it's important. Well, too bad. Anyways, and then we actually need to register our handlers with this router. So g.get, g router.get, and then our handlers, and then r.get, and I need to pass the URL /save. Save, comma, yes, slash go, comma, h.get. Not db.get thing to lsp get URL. Yes. And then I don't need those ones from the standard library. And then the difference is instead of passing new as the last argument to listen and serve, now I pass actually a router. That's just in the end, it just implements the HTTP handler interface. So with that, we should have this middleware called middleware running to every single request we get now. So if we do go run, mode required, I did go get ready. See, I did go get. Go run, go mod died, go run. Yes. Okay, so HP server started. I'll just go to my browser and then I'll try the save URL. And then you can see request started, URL, blah, blah, blah. The handler actually logged something and the request finished. If I actually get another URL that doesn't exist, like 42, and then you see request started, URL 42, method get, start and finishes. So now actually every single request that goes to the router, even the ones routers that are not registered, we actually get the logs for, because it's running through G and the router. Can also code slash. So we have it. And then we can actually start doing some nice stuff, because just logging the URL and the method, it's nice, but we can do nicer stuff. Let me get the G example. It actually already has a meter logger that I want to try out, so you can see the difference from my meter. G. Thank you. G meter, and then I want logger. So if we do r.use logger, and yeah. So now we actually have two logging meters, right? And then I want to show you the difference between them and how they work. If I do go run, go mod type, go run, I think I have, yep. Okay, so go took care of downloading the meter package. And now if I just run, I'm just gonna run slash hello. It's actually not registered in route, but we can see our started, request finished. That's from our meter. That's actually the G meter that we added. That's putting like everything like get, the actual host name and port, the HTTP service running on, and the route, protocol from the connection. And from the IP address, the stats code, how many bytes and how many seconds it took. So it's actually way more richer than our simple URL and method, right? And then if I just do the save URL, save, then you can see our request started save, blah, blah, blah. Our handler actually did its logging, and then you get the log from G, which is very nice. We can actually see everything. We know the order that things happen, right? However, that's true because we're making one request at a time. If we actually have an actual server running somewhere, you're gonna have hundreds of requests per minute, thousands of requests per minute, and then the actual log lines are not gonna be like that. You're gonna have a mix of everything, of those different meters and things running. Let me see actually if I can show that. No. Do I have it installed? No. I don't think I'm gonna manage to actually show it. But yep. But what we want to do, it's actually we want. Let me run just to show it again. What we want to do is for every log line of the same request, we want to be able to aggregate them somehow, right? And how can we do that? And that's where the structured logging comes in. And let's go to the browser. I'll show you a library that I like. So we have this logger called zerolog. There are many other structured loggings libraries there. And the idea is you can actually start adding key pair to your logs. So here we have like access, database, the host, PID, and time, and everything. And then we can actually introduce even something else that's actually an ID, like a request ID, a tracing ID, and then propagate throughout our application. So let's first start using zero log. So go get, yes, go get zero log. If you go back here, it says you can just create, let's see the examples, contextual logging. You can have also log levels. That's another thing that adds, and then you can actually add that stuff. So I got zero log, and then let's quickly go back. Am I on the browser? No. Yeah, that's what I wanted to show. So of course the library has got many examples. The simplest just print, and it's going to start outputting as JSON. We can change that later, but let's focus on actually getting stuff logging. And leveled logging, what's the contextual logging? You can actually start adding your key pairs to the log message, and then you have them. So let's quickly look into that, and then see how we can actually start aggregating those logs. So if we go back to the code, we need to do you can just import actually zero log as the log package, but I don't want it, so I'll do web.com/rs/zero log/log, and the code that z log, and I can't save before I use it. Font, you're too good sometimes. .info .msg, and just a string here. I'll just pass a string quickly, and my import should be right. Yes, they're working. Yeah, let's be a bit crazy. msgf, and then replace this one. So what I'm gonna do, I'm gonna replace our logging message with zero log, and then we go on from there. Here as well. So oops, it's zero log dot info msgf msg, yes, msg here as well. Log dot info msg, have the parentheses, and here as well. Let's use multiple cursors. Nope, that one's not print. Let's be fancy. Multiple cursors. Z log dot info dot msg, and msgf, msgf, and msg. And now we should have a JSON logging. And now, okay, go get, go run. Two main arguments to cause your log info image. You have string, one string. I can't do. Mischief is right. Those ones are wrong. Percentages. Ta-da. Here the same thing. Percentages. S, yeah, not SX. Mischief. Okay. 986. That's MSGF. Okay, so we have the log. We already have some information. We have the log level. We have the time. And now we have the messages. And then if I go to the browser and call something You have pretty much the same thing. We have our started request. That's the message. Everything is inside the message. Have the message on the handler itself as one whole thing as well. That G middleware logger we added is not logging JSON because it's of course not using the same logger. So just log in there, and then you have request finished, right? So that's nice. Let's go back. I'm gonna remove the G middleware because we don't need it anymore. And let's look at Zerolog. Zerolog actually has got integration with the NetHTTP. And that's what I want to show you. So it has this big example here. So what we want to do is we want to create our own logger. Alright, add some fields to it, right? And then put this logger inside the context, the request context. And then on the handlers and middlewares, we can actually access the logger that belongs to that request, that's aware of the request. And then we can do some nice stuff. So I'm just gonna copy the first examples here. And we need something else. No. And I'm gonna copy it with normal copy. Go back to my Emacs. Yes, you can see the Emacs. So actually I'm gonna do that as a very just after the config. Okay, so I don't wanna log. I wanna logger because the package is called log. I don't want things to get confused. For now, host, I think I can get with os.hostname. It's a function that returns a string and an arrow. You know what? Just for the sake of simplicity, let's not put the host name there. We don't need row, but one timestamp. Just call that. I just put a foo bar. So I'm just adding a field. If you look at the documentation, Zerolog has got functions to every kind of type, like str for a value that's string, int for a value that's int, and so on and so forth. I don't need alice, that's just middleware. I don't need that, and I need to copy that and put as middleware on my gr.use. And it's gonna use the logger. Okay, now everybody's happy. And what I want to do is, if I go back to my middleware, instead of using the zlog that's actually a global, what I want to do, I want to get a logger from my context. So there's a function on zerolog, zerolog.ctx that receives a context and returns a logger.context. And then we just replace here by logger and here. I'm gonna only replace this one so we can see the difference. Go back to the terminal, stop that program, start it again, and of course, go mod type. Okay, so level info time message port. So that doesn't have that full middleware message, but where did I put the full level info? We should be seeing the full on our middleware. Our middleware is not running. What is it? Now let's start live debugging. So we get in the logger from the context and we log in here in the middleware. I know what's going on. And what we need to do is first we add the middleware with that adds the logger to the context, then we add our middleware. That's the thing about HTTP middlewares. Some of them need to be in the right order, and especially logging needs basically to be one of the first ones. Otherwise, the other ones they might expect a logger and are not going to have a logger. So, and then we actually can see the difference. So that's using the global logger, so it doesn't have that full bar field. But then if you run, and if I did things right, which seems that I did, the other one we have level info, full bar, the time and then the request started. The logging from our handler doesn't have the message because I didn't get from the context. And request finished also has the full bar, right? So if we go back to your function, then what we can start doing, actually, what we need to do is in every handler be able to log stuff with the actual logger from the request. We need to add this line here, this logger here, and then to the other one, and of course we need to use it. And then need to use it here. Okay, so we should only have, no, we still have the full log package because I'm not using it here. And here I'm also going to use the logger, that one that I instantiated right here, to log by starting with my full bar. And I'll leave full bar. So we know that we're actually using our logger, not a global logger or something. And then I'll show some, okay. So info, full bar. If I make a request, we have request started, we have request finished, but we still cannot differentiate between logs of different requests. Put a few blank lines, we can, but otherwise we can't. So now comes the fun. How we do that, right? Well, zero log actually already has some other middlewares that are gonna get the logger and add more stuff to it. So let's try to use just add their middlewares, and it has a request ID handler. And then let's see how it goes. Yep. So let's copy the example. Let's go back to our Emacs. Am I Emacs? Yes. So as I said, the meters need to be in the right order, right? So let's edit those meters right after adding the logger meter. And let's do some, let's try to be fancy here and use multiple cursors to edit all those lines. Yes, just no Emacs. I want to remove that. R.use, and that should be it. So here we add the logger to the context, and here we add in lots of information to our logger. And then here we have a middleware. And then in one that actually gets our request, are gonna have those fields. They're gonna have a field IP, user agent, referrer. It does actually have the URL and the request ID. And then the request ID is the interesting one that I really want to show you. Okay, we started. It's not in the context of request, only has the full bar. And then if I make a simple request, I'm just gonna make a request to like hello localhost 3000. Just for you to see. Ta-da. Now it's getting crowded here, but okay, we have level info, we have the full bar, we have the IP address. It looks weird because this one is IPv6. We have the user agent, that is this whole string here from my Chrome. And the interesting one, we have request ID. So if you look at this request ID, it's the same request ID of the other message, the request ended. And then if I actually call like the save, let me put a few blank lines so just make life easier. We have request ID with the message request started and the whole URL. We have our message save URL with the code, and they have the same request ID. And the one the request ended has the same request ID. So using that, we can make sure that everything that's actually using, like it's logging every function, every method in the context of this request actually contains this request ID, and then you can aggregate that later. So if you imagine, even if you just have the logs on a log file, you can just grab them, and then you can grab by your request ID. If you're shipping your logs for some solution like, I don't know, Kibana, Graylog, or any other logging solution, Papertrail, anything like that, that's aggregating logs of this different instance of the same application running different place, you can use it to aggregate all the logs from everywhere. And let's see what we can do here. And yeah, so that is for getting the, like, how actually put the request ID on your logger, right? But that allows your application to make all logs with the same request ID. But if you have a situation where you have multiple applications communicating with each other, you can also pass this request ID and propagate across multiple applications. The idea being, to go to a scratch buffer, so I can scratch. I don't know how to type today. Fundamental mode. So if I have application A calling application B, that, I don't know, calls application C, because we live in the microservice world, nothing can happen within a single application. You can actually have A to generate a request ID, propagate it to B, propagate it to C, and all those applications can actually log with the same request ID. So you know that one request initiated on the outermost application in your infrastructure, propagate it to all of those, and then you can aggregate the logs. How can we do that? So there is no magic, right? You need to make some information to go across your applications. So one very easy way to do that is actually add it to the request headers. Let me see if this actually, the request ID meter already does that. Request ID handler. Let's look at the implementation of the request ID handler. SP restart network space. Yes. So that's the implementation of the request ID handler. And then if you look, it gets the context, does ID from request. Oh, it's actually already getting it. If there's no ID, I'll look into that later. It creates a new one and adds to and the logger gives this update context. And ID from request, let's see how it does it. ID from context. No. So no, it only looks if there's a ID on the context already, but it cannot come from outside. So that's what we're going to implement. And then it sets the header name. What this header name comes from? Oh yeah, request ID handler can pass the name of the header to use as the request. The header it's gonna set as the request. Okay, let me actually show that working. No. Terminal. So if I run application and if I split my buffer and I open another terminal, I did something very wrong. Control C, terminal. Okay, I have my second terminal. I can do a cur minus V to see out the headers and everything. Local host column 3000. And if I jump up, you can see we got a request ID as a header in the response. It's called request ID. So I'm going to actually use request ID as well for that. So what we want to implement is if we have a request ID header present in the incoming request, that is the ID we are going to set in our logger. So we can actually propagate it across multiple places. Just close this buffer. I don't need it anymore. main.go. And we can actually copy some code from here. I want what I want to copy. I want context ID. You know what I'm gonna do? I'm gonna copy the whole middleware because I want to modify the implementation of the middleware. So let's create our new func request ID. Didn't copy everything. Go back to zero log. Let's copy the whole middleware, including the signature, and I'll show you what we're gonna do. So we need to write less code. So the first thing, it calls a request ID handler. That's the function. It's very similar to ours, but it's a function that returns a function that's actually the middleware. So there are two nestings of closures here, right? So we can have the field key and the header name. Do I want that for now? Let's leave it here. So the important part is we do this inception of closures, but the important thing is here we define everything you want, and then maybe I can organize better the code. So here it has this ID from request, and what I want to do, I want to re-implement this ID from request in a different way. Func ID from request, because I'm lazy to copy names, that's going to receive an R, that's a pointer to HP request, and it should return an ID. That's an XID. I don't have XID installed here yet. Can I see the type of that? It's going to return a string. So return an empty string. Okay. So let's see. The idea is I want to actually read from the request headers. I want to get my tracking ID. If the tracking ID is not there, I'll generate a new one and add to the context. And just generate a new one and return it. So my idea being this, my request ID from context is always gonna return a tracking ID. Doesn't matter if it was there or not. If it wasn't, it creates a new one. If it was there, it uses the one that was there. So what I want, I need an ID, make the ID from the request header. So r dot header dot header dot get, and the key request an ID. So that will give me an ID, right? And the way it works is if the header is set, you get a string. If the header is not set, you get an empty string. So if id is equals to empty string, we're gonna have to set an id. Otherwise, we return id. id, not f. Okay, and that I'm just gonna use this same package xid from the xid, the package to generate IDs. Is not like a UID before, but it's the same idea, but it's quicker to generate. And context with ID, I'm gonna do ctx. That's my context. R dot context dot no, it's context with context dot with value. Value from the context. The context the key. So it receives a context that's r dot context key. I'll talk more about the key later. And the actual ID. I think this ID is a string. xid.new returns id.xid. This thing. New ID. String. Okay, my compiler is not helping me much here, but okay. So I get the ID from the header. I look if it is empty string. If it is, I generate a new ID. I think I can do it directly here. Yeah. So I can do ID. Sorry. ID. So this xid actually returns a type. That's not a string directly, but you can convert it to ID, to a string. So I set my ID variable. I put it in the context. I get this new context put back into the request. And yep, not gonna put back in the request. Can I do that? Yes, I can do that. Put back into the request. And I return the ID. Actually, that we should do outside. So yes, I can do, because I'm lazy. So we have our own implementation from ID from request. So what we're doing here is to get the ID from request. That's just gonna always return an ID. I'm gonna rename it later. And then we add it to the context. And then we add this context to the request. I don't need that. 0 log. For now, let's be simple. If the key is gonna be request ID. So I'm just gonna do a few modifications in order. So logger. My dog says hi. Hi, Leo. So we get the context from the request, so we don't need to write r.context all the time. We get the logger from the context. Here I can use just ctx, ctx to be quicker. And then we put the context back into the logger. I don't need colon here, just equals. So how do we actually add fields to a logger that came from a context? So we need to call this update context that has this basically gives you a zero logged on context that you can modify. Because what happens if you just do logger.str or something like that, log.debug.str or info. and that's only gonna be used on that log line you're printing. If you do wealth, it has a, you can do logger dot wealth that actually adds the fields like we did in our main.go, and then it returns a new logger. To actually modify the logger, you need to use this update context, and that's specific from the zero log library. Other libraries are also going to provide you a way to do that. And then what we do is we're going to write our I can just add the name here. And then I'm just removing some safety net that we can add later. Yep. So that's in the context, and I'm gonna use actually instead of this is the field key, and then the header name. So those are the parameters you get in the main function, and then so we had the header on the request, on the response, and then you have the key there. So if my implementation is right, every request, when we use our middleware, let's just go back there to the main.go, and then instead of using this request ID handler from zero log, I'm gonna use mine, and I'm just gonna put it as the first one, just for the sake of putting it as the first one. I'm actually just gonna comment out those two lines just because the log's getting too big. So we have our request ID middleware that receives two parameters, a name of the log field and the name of the header. If you jump there, what it does, it gets the context, gets the logger from the context, generates an ID from the request that basically reads the request ID header. We could actually accept the header name here. String. Header. And then if it's empty, it generates a new ID and returns the new ID. Ta-da. And then here we need to pass the name. I'm pretty sure something's not gonna compile. Anyways, we get the ID from request. I'll rename that later. We added this request ID into the context. So if you need it also it's somewhere else, we can access it. We put the context back into the request. Because we get a new context, we need to change the context from the request and then go the way to do that, calling r.withContext. I actually want, just for the sake of organizing stuff, I want to do that before. Oops. And then you set the header. So we get the ID, we update our logger. That's just a function that's going to be called by the logger. So the order actually doesn't matter much. Yeah, it doesn't matter at all. But yeah, anyways, I actually am going to put it back. Okay. And then we set the header with the ID, not dot string. It's just ID because our ID is already string because we are lazy. We're converting there. And then of course we call the next handler. And if we did everything right, let's do go mod ID. We'll run dot my dog says hi again. And it actually compiles and runs, which is a very good thing. And I'm actually gonna do a cur sequence x. If I do know the cur, let's see, we have a request ID. We have the run the request ID here. still have the full bar. We have the IP. We don't have the user agent anymore because we removed that. So our meteor seems to work. So to set header, if I remember correctly, it's -h and then the name of the header, ID column, and the value my ID. And let's see if it works. And it actually works. See, request ID is actually now my ID. So if this call was actually coming from an application from the outside, I could set my ID, pass to my application. My application is gonna use it on its logs. And then you can actually have a distributed stack trace. Can I save it? I want to call it and save it, and there's a question mark in the URL that I have to escape somehow, that I always forget. Let's try that URL. Mark equals URL http. I don't know. Save slash no save question mark URL equals http column. I think something's gonna fail here. Slash golink.org. Well, actually worked. I don't need curl. Well, yeah, I need curl minus v. So if the curl minus v, we can also see that we got back the same header, the same request ID we passed, and we can see our logs that everything worked and everything contains our very not beautiful request ID. Let's get something more easy to read and to find in logs. Just a bunch of stars. So we have our starting request. We have the actual save URL and then request pin sheet there. And then if we go back to the output of our URL, we see that the request ID was actually set on the response headers. And then if I just don't send the header, we get random request IDs. We get random request IDs there as well. So with that, we can actually propagate this request ID across multiple applications. And then if you do that, and then you have actually any tool that can aggregate logs, right? If you have something like Kibana or Graylog that aggregate logs of main applications, you can just use that to filter. If you just have log files, you can just merge them, grab them together. It doesn't actually matter the tool. The important thing is you have one identifier in all your requests. And of course, actually, I'm not sure if I have time today. If you make a request out, we actually need to add this ID to the request out. And I'm thinking how I can demote that. So first, let's rename that. Not ID from request ID, and blah blah blah. Imported from place required. What? Name. Request ID. Okay. Now I have a request ID. Just have a better name for my function. We have a login meter. I'll keep it there. What we can do, we can make our application call itself. Just for fun. So we can actually see how one application can actually propagate the requests to the other. It's going to be a actually interesting exercise. So func echo, and that's going to be an HTTP handler. The WHTTP dot response writer our pointer to HTTP dot request, and doesn't return any value. So echo is gonna echo. Uh, so let me show you something interesting. Golang is actually an amazing programming language that has got an amazing tooling. So there is a package called HTTP test. Let me see if the HTTP test what I want. Recorder server, not HTTP Uchus maybe. Golang. Oops, dump HTTP request. How to dump? HTTP Uchu. Okay, so we have this package called HTTP Uchu, net HTTP Uchu, that has this very nice function dump request. What dump request does basically is gonna get your whole request and return as a slice of byte. So it's HTTP Uchu, right? So let's go back to our Emacs and we'll call it data and our HTTP Uchu dot dump request. It receives a request and a boolean that whether we want to dump the request body or not. I'll say true for that. Yes, we do. Okay, so we get an error. So if error is different than nil, we do something. If not, I'll handle the error later. We want to basically write everything back to our user, like the request we received. So it can just be very lazy w.write data. It's gonna set the content type to text plain, that's fine. And here we can do 0 log.ctx or .context and .error. So 0 log has got this nice error function that actually adds the error in the field error, the error message. Dot msg cannot dump request. Let me see if I forgot. Yeah, that's it. So we have our echo middleware. And let's just register it quickly. And then I'll echo. Let's see it in action. I have to run again the application, split again the screen, get the second terminal. Hi, I'm just gonna call hi. No, I need to call echo. I don't want to minus v. What I want to do is what's going to be the output. So if I call echo, I get my request back. So it was a get / echo the host localhost 3000 accept headers. It was a get request, so it doesn't have a body. What I can do is if I close this terminal and I change my browser, I'm not going to change the screen here, but I'm just going to make the request localhost. Hello, no, I need to change the browser. If I call echo on the browser, we see all the headers that actually the browser is setting, right? So echo seems to work. If it was a post request, we'd get the body. Go back to our Emacs. If you go to the second terminal, and then if you do I'm lazy, request ID on echo without the minus v, you see that the incoming request had a request ID. and then actually works. So what I want to demo is, oh, this thing keeps opening. We have echo, and then I want to show how to actually propagate this request ID to other applications. So func, I'm gonna call ourselves. So recursion. That is my. I'm lazy to type, and I'll copy that. And something wrong here. Whatever. Let's type w.hp response right. R, that's a pointer to hp.p.request. What else? And this recursion, actually, I want to show that if call recursion, I want to show how actually we can call something and pass the header. One way of doing that, very simple one. So we're gonna be very simple here. I can do that. I need to make an HTTP request. So I need a new request. This thing can break, of course, because everything can break. P.new request with context. I don't need the context right now. You should always use request with context. Request with context. So what this is gonna do is gonna create me a new request with the same context that I'm passing. It's a method get and a body. Method is get. It's gonna call someone and there's no body. So it's, yep. Okay. So I wanna call http column / local host column 3000 column echo. I'm not gonna ignore the error. R is different than nil. Actually, let me do something. That's something I like to do. I get the context on top of my handlers. Context. And I get the logger. Log.ctx. ctx. So I can use them, my handler without having to type everything. ctx and error msg cannot create request. And what was the HTTP error function that I forgot? And then we read an error, so it should return not found. No, we didn't do. Okay. If there's never gonna start right starts internal server error and gonna do w.write p.text text on http status internal server, not the best implementation, and return, but it works. And I actually want to make the request, so have the dot header. It's not a function. Set request ID and request ID function header string. We can actually use your request ID function to get the request ID and set on the context. And I'm just gonna set another one just for fun. Foo bar, because it makes it easier to see that was from this actually handler. And then you can just execute this request. http dot get default client dot get. No, there's http dot do, right? No, yeah, http dot default client dot do. Get the request and then return the and then have a response and error. So if same shenanigans, different than yield, do something and bye bye. And actually I want to log code do could not execute request out to, and I'm actually gonna do gf and I think that should work. What I'm doing, I'm logging that I cannot make the request, and actually the URL I called in return. Don't know why my language server is misbehaving, or I did something very wrong. It's also possible. Oh yeah, that's a slice of byte. I need to convert that to slice of byte, because that thing returns me a string. And now I just complain the request ID is complain something, because I need to receive a request, and I need to use my response. So if there's no error, for so that's a very important thing. Every time you do a request out, you have to close the response body. That's one of those little things in Go that can bite you. So the way the do method works, and then if you look at the documentation, if the error is not nil, then you have a valid response, which means that there's a body there that needs to be closed. When you close this body, actually it makes you close the connection to whomever you called. And then if you don't do that, we start accumulating those open connections. And then if it's actually a service that's running, like long running service, at some point you're going to start to have too many open connections, or too many open sockets, or too many open files errors. So remember to do that. Usually if you do a CLI or something, like you run for a few minutes and stop, you never see the issue happening. But if you send something to production without closing the response body, when that error is, this error here is nil, then you're gonna face problems at some point. So just make sure you close the body. And do you want to write something? No, we don't want to write anything back. So I was just gonna write something like, okay, something like it works. It worked. So when we call recursion, it's gonna make a call to ourselves. That's gonna call that echo endpoint, and it actually added the request ID and the full. No, I want to read the response body. Let's defer this call. because echo is gonna actually return the request that it received, and that's what we want to see. So instead of writing that, I need to read the whole response body. Can I call write multiple times? No. I if I remember data, let's see. If I remember that on top of my head, io utu.read. Oh yes. Body. If r is different than here, we copy and paste. And we do a proper error handling. Not read response body. Not read response body and write data. And we just need to rest of that now. Dot get rec. Just go rec because I'm lazy. And it's recursion. Recur. Not working. Did I mistype something? Probably mistyped something. So go up, 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 down. Call the name, and then you save. Remove that extra F. At one of the terminals. It actually works. So our code compiles. Don't know if the code works. You get the second terminal. So what we want to do is call hack. So hack's gonna call echo, and then return the response from echo. So you're gonna see on the logs the call from echo, and then you're gonna see the request IDs being propagated. And something didn't go right, of course. Hack echo request ID request started echo. What have happened? Request finish it. And we have not put from curl. That's interesting. Oh, anyway, there's one interesting thing I can show you. So we have this request ID from the /rec, and then another request started with a different request ID, which means something didn't work. And then this other request finished it, and then that the request ID from rec, it's here. That's the one that finished it here. So at least you can see that like the logs from different requests can get mixed up in the order they're printed, but if the request ID, you can actually get them. And I don't know why this thing's not working. So I know why. Because I need to read the body of the response, not of my incoming request. That was a get request that doesn't have a body. So if we go to terminal 1, go run terminal 2. Ta-da! Okay, so now we have recursion. So the response from the recursion is actually the response from echo. right? Then you can see this request ID that ends in 6Q0. That's actually the request ID from Echo. And then you can see each one has their own request IDs. So mission accomplished. And then we can be nice. And then you can do minus, why can't I type minus H? Request ID 1, 2, 3. And then if we send this request, our logs should have request ID 1, 2, 3, and also the response. And tada, 1, 2, 3, 1, 2, 3, and also the response has 1, 2, 3 here. So basically now we know that the client that outside from our application, we started the request, already passed the request ID. All the requests for our one application, or there could be multiple applications in our infrastructure that got together to answer this request, used the same request ID. And I think that's it for today. I hope it was interesting. I hope you learned something. Please leave a message in the comments. The video is going to be available later, so the comment section should work on YouTube. And I'll see the comments, or then reach out to me on Twitter. My Twitter link is also my YouTube channel. And if you have suggestions for the next topics, please put there. The next video the next live stream should be in 2 weeks. So my idea is to keep every 2 weeks. I hope I can maintain that. So let's see. So thank you very much, and see you next time.